Hi friends, my name is Apparao, working as Associate Professor in Computer Science and Engineering Department at Marri Laxman Institute of Technology and Management, Dundigal, Hyderabad, Telangana State. In this lecture video, I want to discuss about network layer routing in advanced computer networks. So, in this course, I have discussed course objectives, course outcomes. So, in my previous session, for this lecture, I have referred computer networking, computer networks and internet textbooks and a partial guide to advanced networking, computer networks reference books. So in this lecture video, I have taken the reference from tutorialspoint.com and Geeks for Geeks organization. So now network layer routing. So when a device has multiple paths to reach destination, suppose for example, I want to transfer the data or else I want to exchange the data from one device to another device. So obviously, we have a multiple paths to reach destination. It always selects one path by referring it over others. So obviously, if we send the message from one device to another device, so there must be a one transmission media, right? So in the transmission media, so there are number of data will be exchanged. So for that purpose, so it choose one path by preferring its others. This selection process is termed as routing. So this selection is called as routing, as we know that routing is done by special network devices called routers. Suppose for example, see if we provide a router, so that is one device, so where routing table data will be stored, so for sending and receiving the messages. It can be done by means of software process. So the software based routers have limited functionality and limited scopes. So this is the functionality of the router. So enabled software is available. A router is always configured with some default route. So obviously you didn't provide. So obviously, so the route may be provided. See, if you didn't mention the route for a source to destination, obviously router itself maintains, so allocates the one route. A default route tells the router where to forward a packet if there is no route found for specific destination. Suppose here I have a device 1, so device 2. So in between this I provided one router, right? So if you didn't mention the route for particular device, so obviously router itself maintain the route table. So in case there are multiple paths existing to reach the destination, router can make decision based on the following information: how it sends the data or else exchange the data. So these are the following information to maintain the destination path. So hop count, bandwidth, matrix, prefix length, delay. So based on this, router itself allocates the path or else destination from source to the destination. Routers can be statistically configured or dynamically length. So one route can be configured to be preferred over others. So now network layer routing, unicast, broadcast. So these are the two network layer routings. So now I want to discuss about unicast routing. So most of the traffic on the internet and intranet is known as unicast data or unicast traffic is sent with a specific destination. Suppose for example, I have a source and a destination. So from source to destination, if you send the message or else data or else exchange the data, so obviously, so in between this there are n number of routers or else n number of devices or n number of stations are available. So most of the traffic on the internet is known as a unicast. So data or unisend traffic is sent with a specified destination. Routing unicast data over the internet is called unicast. Obviously in the internet, unicast data, suppose here I want to send, right, data source to destination, that is called unicast data. It is the simplest form of routing because the destination is already known to the user. So you know the destination address. If you know the destination address, based on that address simply we can send the data, that is called unicast. The router just has to look up the routing table and forward the packet to next hop. So based on that, so sending data to the next router. So from that, sending the data to the next, so final destination will receive the data. Next, broadcast routing. By default, the broadcast packets are not routed and forwarded by the routers on any network. So if it is a network, sending and receiving data is obviously possibility is there, right? The routers create broadcast destinations. So now router itself creates the destination path, but it can be configured to forward broadcast in special cases only. A broadcast messages is defined to all network devices. So suppose for example, so this is my destination, this is my source. In between this, I have a router, right? So I have another device also, that is C device. So from A to D, I want to send a or else exchanging the data. So suppose I didn't mention the destination address. So what is the importance of router in the sense? Obviously it maintains the routing table, or else it creates the destination path by using this thing: hop count, bandwidth, matrix, prefix, delay. So now broadcast routing can be done in two ways. A router creates a data packet and then sends to each host one by one. Age old story. In this case, the router creates multiple copies of single data packets. Suppose, so for sending data from source to destination, so in between this, if we have another device, so the copy is maintained each and every device. Suppose I have another device called D or else E. So if we reach the data to E also, E itself maintains the one copy. So this is a bit drawback in network routing layer. So because sending the data, exchanging the data, so if it is a number of devices available in between S to D, so it maintains one copy for each and every device. That is a drawback. Now all packets are sent or unicast, but because they are sent to all, so for each and every device may receive. It's simultaneous as routers is broadcasting. This method consumes lots of bandwidth. So bandwidth is high compared to others, and router must destination address of each node. For each and every router maintains the destination address also. So why we have to mention the destination address in the sense for each and every device? So obviously if you miss the data, so then and there itself we can rectify. So where we lost the data, so there you can resend the data. That purpose only is we have to maintain the destination address. So secondly, so when router receives a packet that is to be broadcast, so it is simply floods those packets out of all interfaces. All routers are configured in the same way. For each and every router maintains the same data. For example, here is the source and destination. So now sending data for each and every devices. This is also device. So here address will be maintained, here also address will be maintained. So this method is easy on router CPU but may cause the problem of duplicate packets. Suppose, so if we send the packet P1 and P2, so copy is maintained in this device. So from here to here, so here also one copy is maintained. That is the drawback here. Reverse path forwarding is a technique. To avoid this situation, reverse path forwarding is a technique in which router known is advanced about it predecessor from where it should receive broadcast. This technique is used to detect and discard duplicates. So to avoid or else to delete or else to detect the discarded duplicates, so we have a concept called reverse path forwarding. So next one is multicast. So here destination 1 and destination 2. So here only source 1. So from source 2, so multiple destinations also we can share or else exchange the data, as we know that. So multicast routing is a special case of broadcast routing with significant difference and challenges. In broadcast routing, packets are sent to all nodes even if they do not want it. So suppose sending packets from source to destination is the ultimate goal. So in between this we have a number of devices. So here also maintains the data. So if the device wants or not, so it will be maintained. Multicast routing. The data is sent to only nodes which wants to receive the packets. The router must know that there are nodes which wish to receive multicast packets, then only it should forward it. Multicast routing works spanning tree protocol to avoid looping. So obviously network layer protocol maintains spanning tree protocol. Multicast routing also uses reverse path forwarding. So what is the advantage of reverse path means? It deletes the packets, unwanted packets, to detect and discard duplicates and loops. Next, anycast routing. Anycast packet forward is a mechanism where multiple hops can be some logical addresses. Here, multicast routing maintains packets from source to destination. In between that, if there any device, so it will be maintained. So here, anycast packet forwarding is a mechanism where multiple hosts can be have some logical addresses. When a packet destinated to this local address is received. See, if data is received, it is sent to the host which is nearest in routing topology. Suppose here I have so from here to here destination is bit high. So let's assume weight is 30, so weight is 10. So obviously this path will be chosen in anycast routing. So source, anycast, anycast, anycast. See here we have to maintain the DNS server. Anycast routing is done with the help of DNS servers. So whenever an anycast packet is received, it is inquired with DNS to where to send it. So obviously DNS provides IP addresses for your packet. So obviously DNS maintains the data. So which is the nearest IP, configured it. Suppose this device belongs to so and so particular server. Obviously this information, this type of information will store in the DNS servers. Now unicast routing protocol. So there are two kinds of routing protocols available in unicast packets. First one is distance vector routing protocol, link state routing protocol. So now distance vector is simple routing protocol, so which takes routing decisions on the number of hops between source to destination. So a route with less number of hops is considered as the best route. So every router advertises it set best routes to other routers. Ultimately, all routers build up their network topology based on the advertisements of their peer routers. Suppose, for example, routing information protocol, by using this protocol, it maintains the data. Suppose source, destination 1, destination 2, destination 3. So here, exchanging the data from source to D1, D2, D3. So there, all routers build up their network topology. So by using this topology, data is exchanged. Link state routing protocol. Link state protocol is strictly complicated protocol than distance vector. Compared to distance vector routing protocol, that is bit complicated. So why is so it takes into account the states of links all the routers in the networks. For here, so all the states will be maintained, especially in link state routing protocol. This technique helps routers build a common graph of the entire network. All routers then calculate their best path routing process. For example, open shortest path first and intermediate system to intermediate system. Next one is multicast routing protocol. Unicast routing protocol use graphs while multicast routing protocols use trees, as we know that. Spanning tree to avoid loops. So the optimal tree is called shortest path tree. So here distance vector multicast routing protocol, multicast open shortest path protocol. First CBT core based tree, PIM protocol independent multicast. Protocol independent multicast is commonly used now. So it has two flavors: PIM distance mode, PIM spares mode. So this mode uses source based trees. So this mode uses shared trees. Thank you for watching this video.